All right, so let's continue our discussion of polynomial functions. And in this video, I want to talk about determining what the end behavior of a polynomial is. We talked a little bit about this in the last video. I graphed 4 functions for you, just a quick sketch. I graphed you a line with positive slope, a line with negative slope. I graphed you a parabola that opens upwards and one that opens downwards. Okay, and we said that the end behavior is the arrows, whether they're pointing up or down on the right and left. And we determined that completely by looking at the leading coefficient and the degree. And this is going to generalize to polynomials. This is generally true. All right, so when you have an even degreed polynomial with a positive leading coefficient, it's going to behave like a parabola. That's an even degreed polynomial, x squared, with a leading coefficient that's positive. It opens upwards. Okay, we saw that polynomials can wiggle around a lot in the middle. So it's going to start upwards, and then it might do some sort of strange stuff in the middle, depending upon all the rest of the terms in it. But then in the end, it's going to end up high. So we say that this graph starts high and ends high. All right. Now, if it's an even degree, let's stay in that column, but we give it a negative leading coefficient, it's going to do like the negative x squared, start low and end low. And again, because it's a polynomial, it might do all kinds of crazy roller coaster stuff over here in the middle, but the 2 arrows in the end are going to point down, starts low, ends low. All right, for the odd degrees, we're going to use the lines to help us remember this. Remember mx plus b, the x to the first power is the highest exponent. That's an odd number. Okay, so if you have an odd degree polynomial with a positive leading coefficient, that's going to be like your positive slope line. Okay, it's going to start down low, and then it's going to do something in the middle, and then it's going to end up high. All right, and our last one is if you have an odd degree with a negative leading coefficient, that's going to be like that line with a negative slope. It's going to start up high, wiggle around here in the middle, and then end down low. Okay, so you can have this chart on hand anytime you want when you're talking about polynomials, or you could just kind of remember the graphs of lines and parabolas, which you're already pretty familiar with. All right, so here's 2 of our polynomials from the last video where we determined the degree and the leading coefficient, and we just want to use that information to determine the end behavior. All right, so I've got f of x equals 2x cubed minus, who cares, right? We're doing end behavior. We only care about that leading term. We know that our degree is odd, the x cubed, and that our leading coefficient is positive. All right, so for odd positive, I'm going to be in the top right-hand corner of that chart. So I know that the graph is going to start low and it ends high. All right, so it might kind of do a little wiggling around like this in the middle. I don't know, we could check on Desmos. All right, but we know it's going to start low and end high. All right, so our second one is a degree 4 polynomial, right? We found that one had the highest exponent hiding in the middle. So our degree is even, an even number, and the leading coefficient was -6. All right, so it's an even degree negative leading coefficient. So that's going to put us in the bottom left-hand corner of our chart where it says we're going to start low and it's going to end low. And off the top of my head, I have no idea what this thing looks like. Okay, so it might kind of come up and wiggle around like that, maybe. All right, but I know for certain it's going to start low and end low. All right, so that's all we need to get out of the videos. We're going to talk about the intercepts of a polynomial when we meet together in class.